Okay. So, hello. We will be measuring the centripetal acceleration of the Enterprise ride at Valley Fair. So when you're in your individual car, when you're riding in, here you are. So, you have a normal force going this way, and then you have gravity pulling you down. If you had to draw a force body diagram of that, it would be mg Fn, normal force, and then here we have the normal force cosine theta, and then here we have normal force sine theta, because it represents the normal force in the x and the y directions. Okay, to solve for centripetal acceleration, we need the equation. The sum of all forces in the x direction is equal to the mass times acceleration in the x direction. The sum of all forces in the y direction is equal to the mass and acceleration to the y direction. Because it's going in this, because of the way that it's moving, the acceleration in the y direction is 0. So, the sum of the forces in the y direction is equal to 0. And we also know that the only forces that are in the y direction are force normal times sine theta and mg. So, force normal times sine theta minus mg equals 0. We can move the mg over, so we'll have force normal times sine of theta equals mg. And then just to get the normal force by itself, we can set Fn equal to mg over sine of theta. So, what do we do with that? Well, we look at the other equation. Because all acceleration is in the x direction, we know that the centripetal acceleration has to be equal to the acceleration in the x direction. So, the sum of the forces in the x direction is equal to mass times the centripetal acceleration. We also know that the only force going in the x direction is normal force times cosine theta. So normal force times cosine theta equals mass times centripetal acceleration. From this equation, we derive that normal force is mg over sine theta, so we can just plug that into here. So mg over sine theta multiplied by cosine theta is equal to the mass times the centripetal acceleration. Using our trig knowledge, we know that when cosine is divided by sine, it turns into cotangent. So it's the same thing as cotangent. So we have mg of cotangent theta equals mass times centripetal acceleration. Using our algebra skills, we can cross out the masses on both sides. So we have g cotangent theta equals centripetal acceleration. Using the video that you've seen before, we can measure the exact angle, which we measured to be 28 degrees. So, plugging that in for theta, we would have g multiplied by cotangent of 28 degrees, make sure your calculator's in degrees, is equal to centripetal acceleration. We all know that the gravitational constant, the free fall constant, is 9.8. So, G is 9.8. You know that. Okay. So, 9.8 times cotangent of 28 equals centripetal acceleration. You plug that into your calculator, and you should get that centripetal acceleration is equal to 18.431.